So let's keep going. And now we're looking at more advanced equations. So when the coefficient on x squared is not 1, the first step you want to do is see if you can factor out the greatest common factor from all three terms. Sometimes you can do it and sometimes you can't. In this case, we can factor out 2 from all three of these terms because they're all divisible by 2. So let's pull that out. You get x squared minus 20x. We're essentially just dividing everything by 2 plus 100. And from here, we can just factor using that reverse FOIL method. So I'll put the two binomials, and we have two terms in each of these. And we know the first ones, this one and this one, will multiply to x squared. So that would be x and x. And the last ones, so this one and this one, would multiply to give us 100. So what are the different combinations of numbers that multiply to 100? So it could be 1 and 100. It could be 2 and 50. It could be 4 and 25. It could be 5 and 20. It could be 10 and 10. And it could also be the negative cases. But at this point, I actually notice the one that'll work. If they're both minus 10, then when we add them together, we do get the coefficient on x. We do get minus 20. So minus 10 and minus 10 would work here. And to check your work, I encourage you to pause your video, re-multiply this out, and make sure that it does equal what's in parentheses here, this quadratic expression. So we were able to factor this, and this is actually a perfect square since we got the same thing twice. And now we just use the zero product property. We ask what numbers can we put in here and here such that the expression would simplify to 0. In this case, it would be 10, and as well here. So in both cases, you get 10. And so this is again that case where you get just one solution, but it's the same solution twice. So if we plug in 10, you get 10 minus 10, which is 0, and we'd have 0 times 2, but 0 times anything is 0. So 10 is what we put in the box, and if you really want to make sure this is right, you can plug 10 back into the original equation, and you'll see that it would simplify to 0. So we can keep going. Got another quadratic where the coefficient on x squared is not 1. And so we can start by trying to factor out the greatest common factor. And all three of these terms are divisible by 6. So we'll factor a 6 out, and we have x squared minus x minus 12. And this is still equal to 0. So we can set up what we're going to factor this into, these two binomials. And we know there's two terms in each. And we know that the first ones are going to give us our x squared term. So this will have to be x and x. And we also know that these last two are going to multiply together to give us negative 12. So let's write down the factor pairs of negative 12. And those factor pairs will have to essentially add together to give us negative 1, the coefficient on the x term. So for negative 12, it could be 3 and minus 4, or minus 3 and 4. It could be 1 and 12, where one of them's negative. So minus 1 and 12, or 1 and minus 12. It could be 2 and minus 6, or minus 2 and 6. But you can see that minus 4 and 3, if you add those together, excuse me, let me back out just a little bit again. If you add those together, you would get minus 1 here. So we have plus 3 and minus 4 in our parentheses. And now we can use the zero product property. Since we know if we plug in negative 3 there, and if we plug in 4 there, then each of these sets of parentheses would simplify to 0. So we would do it one at a time. You only want to submit or substitute one x value at a time. But if you put in negative 3 here, this would be 0. And then you'd have minus 3 minus 4, which is negative 7. But 6 times 0 times negative 7 is 0, because 0 times anything is 0. And likewise, for 4, this would be 0, and this would be 7, but 0 times 7 times 6 is 0. So our solutions are negative 3 and positive 4. And we can plug those into our box up here. So the lesser one is the negative one, and the greater one is the positive one. And let's do one final example, where again we have this opportunity where we can factor out a greatest common factor. So let me just rewrite it, but our first step is always look at all three terms and ask if there's anything that would divide evenly into all three of them. And in this case, you can pull out a 5. So after dividing them each by 5, you'd have x squared minus 4x plus 3 equals 0. And we're going to factor this into a product of two binomials. And the first terms in each we know are going to give us our x squared terms. So this is x and x. And then our last ones, this one and this one, will multiply to give us positive 3. So we need to ask, what are the possible factor pairs for 3? And that would be 1 and 3, or minus 1 and minus 3. And then to decide which one of these is the one that we'd use, we know that they have to add up to the coefficient on x. So in this case, minus 4. And that would be this one, minus 1 and minus 3. So we can put minus 1 and minus 3 into our expressions here. And at this point, we just use our zero product property. So which x values would you plug in here or here to make each of these expressions equal to 0? So in this one, it would be positive 1. And in this one, it would be positive 3. If you put 1 in here, this becomes 0 times by 1 minus 3, which is negative 2. And 0 times anything is 0. And the same would be true here. 3 minus 3 is 0. And over here, you'd have 2. So 0 times 2 times 5 is 0. So our solutions are 1 and 3. And both of those are positive. So we can put them in the box. Our lesser one is just the smaller one, 1. And the greater one is 3.